Well, hello there, and welcome to the latest installment of 1 minus 2 equals negative fun. In today's episode, we are going to take a look at identifying combined transformations. So we have looked at 4 types of transformations in class. We have seen reflections, rotations, translations, and dilations. Today we're going to look at identifying combined transformations, so when you have more than one. So if you would take a look down here on your graphic organizer, and you'll see that we've got a coordinate plane with 3 triangles on it. We have the original, which is here in blue, ABC, and then we have the first transformation, or the first image, which is A prime, B prime, C prime, and we know it's the first image because it only has one prime notation. And then you have A double prime, B double prime, C double prime. And what we need to determine is what combination of transformations occurred to get from A, B, C to A double prime, B double prime, C double prime. So from the original to the final image. And our first step, or step one in the process, is to organize the information. In our table, I'm going to list what we have as triangle ABC. Again, I know it's the original because there's no prime notation. And all I'm going to do first is list the coordinates. So to organize my information here, A is -5, 7. B is -1, 7. And C is 0, 2. I'm just going to continue to organize my data, and I'm going to list the coordinates for our first image, which is A prime, B prime, C prime. And the coordinates for A prime are over 2, up 6. So this is 2, 6. B prime is 6, 6. And C prime, which is 7, 1. And then I'm going to continue this process of identifying the information, organizing the information, and I'm going to list triangle A double prime, B double prime, C double prime. So for A double prime, the coordinate is 6, -2. And for B double prime, the coordinate is 6, -6. And for C double prime, the coordinate is 1, -7. So now that I've organized the information, because step 1, organize the information. Now step 2, I'm going to look for any patterns that occur. So I need to look to see, were there any patterns? And to do this, I'm just going to list down here below, as if I'm writing the rules in arrow notation. And this is going to help any patterns stand out. So if we look at the first image here, or the original, I mean, we can look at this and we can see that it's facing the same direction, so the orientation hasn't changed. And since the orientation hasn't changed and the size hasn't changed, it's pretty apparent that I'm looking at a slide or a translation. So all I'm gonna do is count from coordinate A, and I want to count to see how far over did I go. So all I want to do to determine what occurred from the original to the first image, I'm just going to count from A, and I'm going to count over to see how far did I go. So from A, and we go until we get to A prime, and we went 1, 2, 3, 4, 5, 6, 7. And since I went to the right, I'm adding, so that's x plus 7. And then I want to see, did I go up or down? Well, I went down, and I only went down one place. And since I went down, that's minus 1. Now from here, we can look at the image, and we can see that it's facing a different direction. The orientation has changed. So I've either done a reflection or a rotation, but looking at it, and you can tell that the coordinates don't line up exactly, so there had to be a turn of some sort. Now, if looking at it, it isn't obvious, now we can refer to our data points up here and look for any patterns that we see. So step 2 is to look for patterns. So step 2 is to look for patterns, and if we look, we notice transformation, our first transformation to the second transformation, so A prime, B prime, C prime, A double prime, B double prime, C double prime, we notice that the y coordinate becomes the x coordinate, and that's consistent as you look throughout your data. And you'll notice on B prime and B double prime it's not so obvious, so we need to inspect A and C to determine, is that the case? And in fact it is. So y swaps places with x. But that's not as easy as the pattern is, because you'll notice something else happens as x switches with y, and it is the value goes to its opposite. So x is becoming negative as it switches. So now that we've organized our data, we've listed any patterns using the rule or arrow notation. Now step 3, and this is really the big thing, is if we know the rules, that's great, but if we can apply them, then we really understand what we're doing. So if I can apply the rules, well, if we look down here from x, y goes to x plus 7, y minus 1, we know that this is how the rule appears for a slide. If we look down here at our rule for x plus 7, y minus 1, we know that this is the rule, or this is what it appears like for a rule for a slide. And then if we look from the first transformation to the second transformation, we know that if the x and y coordinates switch, we're dealing with some type of rotation or some type of turn. So if we were asked to determine what combined transformations occur to get to our final image, we did a transformation. So now that we've identified that it's a translation and a rotation, we would write, in order to answer the question of what is the combined transformation, we have to say that it's a translation and you have to identify that it's a translation that went right 7 and down 1, and then we did a rotation of 270 counterclockwise we say it's y negative x. So when you return to class, you need to be prepared to answer what is a combined transformation, and how can you tell if the final figure is congruent to the original. And the way that you can tell is the types of transformations. There are 3 that are congruent, and there's 1 that's similar. If all of the transformations are of the congruent transformation type, then your final image must be congruent. Thanks for tuning in.